Math 8, Unit 4, Graphing and Slope. Lesson 2, Part 2, Slope. How do I represent steepness? Okay, so slope is going to be representing how steep something is, and it is just a number. We boil the steepness down to just a number, and we can actually compare the numbers. Steeper slopes have bigger numbers, and that should be the case. Otherwise, the number wouldn't really be very useful to us. So slope is rise over run. Rise is how much y changes, that's the up and down. Run is how much x changes, that's the left and right. And you can have negative slopes, they'll go down instead of up. Now the reason we use the letter M for slope is because not all math was created in English. In fact, most math wasn't. In another language, French, the word for to go up, which kind of makes sense for slope, slope goes up, the word is, well, it starts with M. I don't remember the word, I don't speak French, but it does come from another language. Okay, we're going to draw a line with a slope of 1/2. Now that means that it's got a rise over run of 1/2. So the rise is 1, the run is 2. So from here I'm going to rise 1 and run 2. And then I'm going to repeat that, rise 1, run 2. And I can complete it, I can repeat it as much as I need to. And this gives me a slope of 1/2, a line with a slope of 1/2. Okay, let's draw a line that has a slope of 2. Well, this is going to have a rise over run of 2. Now, we do want this as a fraction, so 2, we change it into a fraction, we'll just put it over 1. This is rise 2 and run 1, and then we get our dot. We go ahead and repeat that rise 2, run 1 pattern as much as we can, and then we get a nice line with a slope of 2. Now, one thing I want you to notice here, 2 is greater than 1/2. And a line with a slope of 2 is steeper than a line with a slope of 1/2. Steeper lines will have greater slopes. Draw a line which has a slope of -5/6. All right, so we're going to be going down 5 because it's rise -5, so that's going to be down, and we're going to run 6. So rise -5 is to go down 5, and then we're going to run 6, and that ends us up right here at this point. That gives us a slope of -5/6. That's actually a little bit harder to draw, so I'll do it with this tool. And there's a line with a slope of -5/6. I don't have enough room to do another dot here, so that will be about it there. Let's draw a line with a slope of 3. Remember, slope is rise over run. We want to have it as a fraction. This is going to be 3 over 1. We've got a rise of 3 and a run of 1. So we'll go up 3 and over 1, and we got our new point. I can also go down 3 and back 1 to get additional points, and we get this as our line. Okay, a slope of -3. This is -3 over 1. We're going to rise -3, which means to go down 3, and we're going to run 1, and that ends us up right here. And there's not enough room to do another one here. We can go up 3 and back 1, and that will end up on the same line. And we get a line with a slope of -3. Now notice, a slope of +3 and a slope of -3, they're the same steepness. One's just a positive slope, the other one's a negative slope. If we were talking about their rates of change, we would definitely say 3 is greater than -3. You're in a much better situation if you can be increasing $3 a day versus decreasing $3 a day. But as far as the steepness of the line is concerned, they're pretty much the same. Okay, find the slope from a table. We're going to find the rate of change between any 2 points. Actually, I want to focus on it as rise over run for today. Tomorrow we'll go over the points in more detail. The rise is how much y changes. And the run is how much x changes. So, as I go from 9 to 5 to 1, all the way down there, I am subtracting 4 every time. As on the x's, I go from 1 to 2 to 3. I am adding 1 each time. So the change in y, it seems to be going down by 4 each time. The change in x seems to be going up by 1 each time, giving me a slope of -4/1, which just equals -4. So the slope m of a line is the ratio of the change in y, the rise, to the change in x, the run, between any 2 points on the line. Today we are focusing just on these first two. We'll talk about this one in the next lesson. So, slope is rise over run, or change in y over change in x. We do have positive slopes. As we move across to the right, which is the direction we read in English, the graph increases. That's a positive slope. As we move across to the right, which is the direction we read in English, it goes down. That's a negative slope. So describe the slope of the line, then find the slope. On this one, A is a positive slope, and it looks like it is going with a rise of 5 and a run of 6. So the slope is rise over run, 5/6. And that's it. The next one appears to have a negative slope. It is going down as you move to the right. So I would do a rise over run, the rise of -3, the run of 2, giving me a slope of -3/2. Now that could be changed to -1.5 or -1.5. It's actually best to just leave it as a common fraction because slope is represented as rise over run, and it's easier to deal with it as -3/2 rather than dealing with it in one of these other two forms. Okay, let's find the slope of each of these lines. What you'll want to do first on these is draw a triangle, a right triangle, between the 2 points. Find the size of that right triangle. Okay, this right triangle, to get from here to there, is down 1, and to get across here is going over 5. This is a slope of rise -1, run 5, -1/5. Notice -1/5 is a number really close to 0. Notice that this line's steepness is really close to 0. It's not very steep. Okay, next one. Let's go ahead and draw a right triangle between the two. Now the triangle can be drawn above or below. It doesn't matter which place it gets put. On the above one, it looks like we are going up 2 and then over 6. Rise is 2, run is 6. So the slope is 2/6. That, of course, reduces to 1/3. Okay, next one. We need to draw a right triangle. It looks like it's over 2 and up 1, 2, 3, 4, 5. So the rise is 5, the run is 2. The slope is 5/2. All right, on a table, as we did before, you just find the change in y, you find the change in x, and then you make a fraction out of it. So right here, going from 1 to 4, then to 7, then to 10, each time is +3. Going from 8 to 6 to 4 to 2 is -2 each time. So the slope is the change in y, the rise, -2, divided by the change in x, the run, 3. The slope of this linear relationship is -2/3. Okay, finding the slope a couple more times here. Okay, right here, the y looks like it's going up by 3, and the x is going up by 2. Slope is y over x, rise over run, 3/2. Right here, the y goes down by 2, while the x goes up by 1, giving me a slope of -2/1, and that will reduce nicely to -2. So the slope there is -2. All right, in the assignment, the first problem, you're just going to draw your right triangles and find your slopes. In the second problem, you need to do the change in y, change in x, and then make a fraction out of it. Rise is y, so y over x, and you've got your slope. Number 3, a review problem solving for y. We're going to be doing that in this unit. Number 4 is a review from last time, but it's kind of extended as well. You're going to graph y equals x squared using a t-chart. And it's not a linear function. You'll have to just fill in the t-chart and then plot the points, and it's not going to go in a straight line. You're going to solve a problem on 5. Number 6, it looks like your review of fractions. Number 7, you're finding the slope of this slide. You're going to have to do some figuring to see what the rise and run of the slide portion is. And then number 8 is going to bring back the idea of unit rate from 7th grade and mix it with slope so that you can start learning how they're related.